My name is Beth Hundy, and this is work I've done with Katrina Moser. We're both affiliated with the Center for Teaching and Learning and the Department of Geography and the Environment at Western University. Today, I'm going to talk about helping students to investigate climate change basics using StoryMaps and a few other ArcGIS tools. Today, I'm going to introduce you to the Connecting for Climate Change Action project, give you 3 examples of how we use StoryMaps in our project, and share my lessons learned. A bit of context as to why I started making StoryMaps to teach about climate change. We are creating an open course called Connecting for Climate Change Action. Connecting for Climate Change Action uses a storytelling approach to braid Western and Indigenous sciences to educate, encourage discussions, and motivate action on climate change. These story maps are a small but exciting part of this larger project and are playing an important role in introducing climate change basics. And it's not just the 2 of us on this project. We're working with our brilliant colleagues, Serena Mendizabal, Sarah May Chitty, Ramon Sanchez, and Amir Aman, as well as Anishinaabe artist Holly Pichette. We want students to be able to explain how global temperatures are calculated and to investigate temperature records at a given location. This story map helps them do so. Let me explain a few key features. On this story map, before explaining, we ask students to think about what challenges might a climate scientist encounter when calculating global temperatures from these weather stations. Basically, how do they get a single average temperature from all of this? Most of these maps are interactive, so students can look at them from different scales or click into them. I really wanted students to grapple with some of these tough questions before we explain how it works. So I wanted to intersperse quizzes with formative feedback. After a brainstorming session with the map librarians, Liz and Jordan, I ended up using Survey 123. To work well, it needed to be in the main panel, so I embedded a smaller version of the graph at left for reference. Students can enter their answers to the questions, and when they click an answer, they receive immediate feedback, so they can make sure they get the right answer before moving on. Then we walk students through the key challenge, the bias towards areas with more weather stations, and how scientists overcome this. That is, a gridded approach. Students are then asked to investigate the gridded approach. This is a KMZ file with the Earth divided into a grid. Students click buttons to go to different locations on the map that we have predetermined and answer questions about the temperature records for each gridded station. Then they look at the records themselves and the length of the record. Then they have a chance to choose a place on Earth themselves, have a look at the length of the record and the trends, and describe it for themselves. Additionally, we want students to interpret climographs to explain key influences on Earth's land temperature. In this story map, What Are Influences on Land Temperature?, 6 key influences are investigated in turn. Students are introduced to how to read a climograph, once again with a quiz and formative feedback to ensure they know how to read them. Then they're introduced to 6 factors in turn. Each starts with a comparison of 2 cities, with prompting questions about why the climate would differ between the 2 and how. Then students can see an interactive climograph and learn about the general principle in play. In this section, students are asked to think about what they already know about surface temperature intuitively, and then they are introduced to the principles at play, like albedo. Students are tested on their understanding of the concept and the ability to read the albedo graph. They then read a more fulsome explanation of the example, comparing the Sahara and tropical rainforest. Finally, an example including Greenland and its albedo is capped off with a map that allows students to see that Greenland is colder than areas the same latitude due to its albedo. This second example, looking at cloud cover, shows the use of dashboards for displaying data. Students are introduced to some general principles about cloud cover, then asked to think about how 2 cities nearby may differ based on cloud cover. Students can spend time interacting with a climograph that shows the differences in cloud cover and temperature. These were created using ArcGIS dashboards where I entered climate data and displayed them. And now my third example is a little bit different. For this, we want students to connect with others over shared and unique relationships with the environment. So we wanted them to take some time just to connect with a local green space. They each are asked to find and then sit quietly in a sit spot. This is simply a green space that they can observe what's around them. Once they're done, they open a survey that was created in ArcGIS Survey 123. The survey has some simple reflection questions about what they noticed with their senses, sitting in a spot for 15 full minutes. Students will collect this information from nearby where they live. They can upload their location and the answers to their questions, and they can also upload a picture. Once they've completed the survey, they can see where other students were sitting and read their reflections. We did this using the web mapping application, but once this course is open to students from beyond just Western, we will be populating a map with student reflections on what it's like to notice nature right where you live. And now for some lessons on what I've learned from using these ArcGIS tools. First lesson is to assess and add formative feedback using Survey 123 Connect. I also provided formative feedback using the same tool, Survey 123 Connect, which is the desktop version. Lesson 2 is to think outside the box for visuals. We used our own data using dashboards so students can investigate the graph. We also found existing embeds. These are interactive graphs that have been made by somebody else. Lesson 3 is to seek feedback and adjust. So we have tested this in Katrina's climate change course this year. Other smaller lessons learned were that StoryMaps worked really well when we expect students to gain independence in interpreting data. We used questions to encourage time on tasks, and students noticed that worked really well for them. Video scripts form the basis of the story map, and that required minimal reworking. In particular, the active voice and video scripts translated well to StoryMaps. I knew exactly what I wanted to do with StoryMaps, but definitely needed help brainstorming how to make it work. Collaborating with the GIS librarians Liz and Jordan gave me new ideas and sped along my own learning.